Another exam type question to tackle today, right? So we have in the diagram alongside PW intersects QV. Where is PW? So this is PW. They say it intersects QV. We can see intersecting lines are lines that are crossing each other, touching each other, passing each other, like crossing. I think it's the right way, right? So T and Z are x intercepts. Okay, T and Z are x-intercepts. We can see that on the diagram, like T and Z are the x-intercepts, right? So far so good. Then we have PQ intersects the y-axis at -6. So this is our -6 here, and we know the value of y there, it is -6, and we know on the y-axis the x is 0, the x-intercept is 0. So we know the coordinates here of this line PQ. So that means our our equation so far for PQ, okay, the equation is not complete yet, but we know it is y is equal to mx minus 6, right? So we know in the normal general formula this one is plus c, but here our c is -6. So we can continue now. Then they say ptz, so let me do that. They say p, okay, p, then t, then z. This is 71,57. Okay, now they are touching the angle of inclination. The equation of pw is given by y is equal to y plus x is equal to 10, right? This is not the standard form. We know the standard form should be y is equal to, then we transpose that x, we get -x plus 10. This is the standard form, and from here we have an invisible one here. That means our gradient for this line, it is m is equal to -1. We can use this to solve for the inclination, the angle of inclination, right? Then they tell us that PW is perpendicular to QV, sorry. PW being perpendicular to QV. Where is PW? So this is PW perpendicular to QV, sorry. Then we know they have 90 here because they are perpendicular, and we know that perpendicular lines, like their product, maybe m1 m2, they should give us -1. So that is what we know by perpendicular lines in analytical. They give us -1, their product is -1. So that was just the statement. I'm going to solve the questions on my next video.